So now in question 3.1 says that we are given this geometric series of 3 over 2 and 3 over 4. Determine the largest value of n such that Tn is greater than 3 over 16384. So the first thing we're going to do here is we're going to write our series, which is 3 over 2, 3 over 4. So this is the first three terms of our series, right? Our geometric sequence. So now since we are told that it's a geometric sequence, we're going to find our common difference, which is t. So we're going to find our common difference, which is r. So knowing that this is a geometric sequence, we need to find our common difference. So r is equals to t2 over t1 is equals to t3 over t2. So if you divide 3 over 2 by 3, which is equals to 3 over 4, divide by 3 over 2, you should get your r as 1 over 2. So this is your value of r. So but consider that the question says that we must find the value of n when Tn is greater than 3 over 16384. So we need to first find this Tn here. So the Tn of a geometric, it's ar to the power n minus 1, and our value of a is this 3 here. So it's going to be 3 into our r, which is 1 over 2 to the power n minus 1. So this is our Tn. So we're going to replace it here. So we're going to say 3 into 1 over 2 into n minus 1 greater than equals to, sorry, so it's greater than, sorry, so it's greater than 3 over 16384. So to find the value of n, what the first thing we're going to do, we're going to divide by 3 both sides, and the 3 will cancel out with this 3 here. So we'll have 1 over 2 to the power n minus 1 greater than 1 over 16384. Just to explain how this 3 will cancel out the other 3, so it's going to be 3 over 16384 divide by 3, and then we have 3 over 16384. We're going to change the sign from divide to times, so this 3 is going to tip, so it's going to be 1 over 3, so this 3 will cancel out with that 3. Fine. So to find the value of n here in this problem here, we're just going to say n minus 1. We're going to use logs greater than log of base 1 over 2, which is our base, and then we multiply with 1 over 16384. So n minus 1 is greater than, we're going to get 14, and then we transpose the 1 to the other side, n is greater than 15. So this is not necessarily a solution. N is not greater than 15. Why am I saying that? If you have your Tn equals to arn minus 1, which we found to be 3 into 1 over 2 to the power n minus 1, right? But the question says that we must find the value of n when Tn is actually greater than 3 over 16384, right? So if you substitute here, n is equals to 16 maybe, because we found n greater than 15, you're going to get, so if you say 3 1 over 2 to the power 16 minus 1, you're going to get a solution of, you're going to get a solution of 3 over 32768. So this value here is actually less than this one here. So your Tn is not greater than this expression here. So this value is smaller compared to this value here. So we need a value that is larger, right? So if you substitute 3 into 1 over 2 to the power of 14 minus 1, you're going to get a value of 3 over 8192. So this is a correct solution because this expression here is larger than this expression here. So you can confirm or conclude rather and say, well, n must be equals to 14 to get the expression that is larger than 3 over 16384. So now in 3.2 we are asked to find the value of p when these two sums are equal. So we are given that the sum to infinity when k is equals to 1 of 27p to the power of k is equals to the sum of 30 terms when n is equals to 1 of 3 into 1 over 2 to the power of n minus 1, right? So what we're going to do is we're going to first find the 3 terms of this sum to infinity so that we'll be able to identify the sum of the sequence, the sum to infinity. So first find the 3 terms for this one, and then for this one here, if you take a look, it's actually similar to the previous problem that we just did. If you look at this portion here, so you don't need to find the first 3 terms because we already know them. We know that it's equals to 3 over 2 and 3 over 4, and our r we found to be 1 over 2. We already know our r, we already know our a, which is equals to 3. So and what we need to note is we will find our n very easily because n is equals to top minus bottom plus 1. So n is equals to our top value, which is 30 there, minus our bottom, which is 1, this portion here, plus the 1, so it's going to be 30. So we have everything for this side, and let's just find the first 3 terms of this one here. So it's going to be when k is equals to 1, 27p to the power of 1 when k is equals to 2, 27p to the power of 2 when k is equals to 3, 27p to the power of 3. Right, we were substituting the k to this power here. So our first 3 terms of this sequence is going to be 27p plus 27p squared plus 27p cubed, right? So our a value is equal to 27p, and then our r, because this is a sum to infinity, our r is going to be 27p squared over 27p equals to 27p cubed over 27p squared. So our r here is going to be p because the p will cancel the p, remain with p, and the 27 will divide out. So your r is equals to p. So now to find the sum to infinity, which is equals to a over 1 minus r, our a value is the 27p, so it's going to be 27p over 1 minus our r is equals to p. So this would be your equation 1, the sum of infinity, right? And let's deal with the other portion. Remember that our sum here, we already know our r being equals to half. We calculated our n, which is 30, and we know our a value, which is 3. So we know very well that we are dealing with a geometric sequence, right? So to write that down, we have r is equals to 1 over 2, a equals to 3, and n equals to 30. So to find the sum of this geometric, so what you're going to do is you're going to say sum of 30 terms is equals to a. So to find the sum, we first write the equation of a geometric. So it's a into 1 minus r to the power n divided by 1 minus r. So the sum of 30 terms is equals to our a value, which is 3, into 1 minus into 1 over 2, which is our r to the power 30, divided by 1 minus 1 over 2. So if you punch your calculator, you're going to get an answer that approximates to 6. So simply write 6. So s of 30 is equals to 6, and sum to infinity is equals to 27p over 1 minus p. And remember that these two sums were said to be equal to each other. So meaning that you're going to say the sum to infinity is equal to the sum of 30 terms. So we want to find the value of p. Remember that. So the sum to infinity is equal to 6 equals to the sum of 30 terms is 27p over 1 minus p. Then we cross multiply, is going to be 6 into 1 minus p equals to 27p. So we're going to multiply the 6 inside here, so it's going to be 6 minus 6p equals to 27p. Transpose the minus 6p to the other side, you have 6 equals to 27p plus 6p, right? And then 6 is equals to 33p, and then you divide the 33 both sides, you have p equals to 6 over 33. So if you simplify, it's actually 2 over 11. So this is your value of p. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comment section below. Don't forget to subscribe to the channel for more videos.